Patterns of disease in population. Disease has many patterns in population. Patterns is like the way it is apparent, the way the disease is occurring in the population. So, but there is one very important pattern that is in time and space. So disease can occur in time and space of four types. That is, we have sporadic type, we have endemic type, we have epidemic type, and pandamic type. So disease occurring in sporadic type, disease which occur rarely without any predictable regularity in the population. It is just a disease occurring without any predictable regularity in the population. That is a disease occurring. When you plot the graph of the number of cases against time, you find out it is somehow irregular. You cannot predict at which time of the year, at which time of the month will that disease occur. So it's just like a disease occurring in the population without a predictable regularity. Probably the disease is there in subclinical cases, in most cases, and only rarely clinical cases do occur. Or you find that maybe the disease causing agent is already exists in the population in a reservoir, and then only those few individuals that are contaminated by the reservoir or they are near the reservoir, then they now get disease, and thereby the disease will now have what we call occurrence without regularity, predictable regularity in that population. So it's like you find out the disease occur in the population, but it is just occur without any predictable regularity. It is just a disease that occur and just die out, occur and die out. So you see, if you see the graph or number of cases plotted against number of time, it will be like this. Number of cases, this is the number of cases, this is the occurrence of the disease in a month. You see, the disease will be occurring, the shape of the graph will be different based on, because it's when you predict it occurs like this, next time it occurs different way. So it will be occurring without predictable regularity. Now, the other disease is what we call endemic disease. Endemic disease. Disease occur in the population in endemic. It's a disease that occurs in the population with a predictable regularity. It is somehow endemic, that is always almost there in that population. The disease occurs almost there. The disease is continually present in that population, and it's like here in Nigeria, mostly we see people with malaria. Malaria become endemic in our population. It's just within that population is always there. It occurs with the what we call predictable regularity. You can regulate it. This is what is happening. There is session that when that session is occurring, definitely malaria will be very high. Sometimes malaria will be very low because of the harmattan. Sometimes because of the rainy season, there are too many bushes area. Malaria, mosquito vectors will be very high, and thereby malaria will be very high. So you can predict the regularity. So when we said now that, for example, a high, you see sometimes high population, high number of population will be affected. Sometimes moderate, sometimes very low population will be affected. But still, it's what we call endemic disease. Endemic disease. So if, for example, a very high proportion of individuals in that population are affected, then it's what we call meso-endemic. I mean, hypo-endemic. A very high population of individuals are affected is called hypo-endemic. If it is moderate population, it's called meso-endemic. Moderate population, moderate number of individuals are affected is called meso-endemic. While if a very low population affected is called endemic. Hyper-endemic. So when you plot the graph of the number of cases against the individual, so it will continue to stay steady with the period of what we call predictable regularity. So the other one, other pattern, drink even if you are not thirsty because the cells are working. So the other pattern of disease in population is what we call epidemic disease occurrence in that population. Epidemic disease occurrence in the population. Epidemic disease, any occurrence of disease in excess of endemic. When a disease is occurring in excess of endemic, this is endemic, maybe malaria is endemic, but sometimes it occurs in excess of endemic. That means it's what we call epidemic. So endemic is expected. That is expected disease occurrence, while epidemic is observed. So when observed over expected is greater than 1, that is epidemic case is occurring. When observed is also greater than expected, that means epidemic case is occurring. And in a normal case, you find out, in an endemic cases, you find out observed is expected is equals to observed. What you observe is what you are expecting. That is called endemic. You find out endemic. So, but whenever a disease is occurring in excess of endemic, that is epidemic case has occurred. You find out the number of cases that contribute to the epidemic depend on the disease itself, types of disease, nature of the disease, and then the population, and then the level of occurrence of the disease in that population. Level of occurrence of the disease in that population. At what level did it occur initially in that population, and what is the nature of the disease? What is the nature of the population? The population, are those population are just congested in one place, or are they separated or distributed evenly, something like that? So if you see inoculated, congested settlement, the population type, you find out disease can be able to distribute much faster than the other disease. You find out there are two types of epidemic. We have common source epidemic, and we have propagated epidemic. Common source epidemic and propagated epidemic. Common source is when the individual in that population share the same common source, the same source of that epidemic, is what we refer as common source epidemic. For example, maybe a well is poisonous. There is somebody poisoned a well, and then maybe there is a reservoir disease-causing organism in a well, and people continue to fetch water. So all those that fetch water and drink water from that well, they have what we call common source. That is what they obtain their own source of epidemic, the disease, from that well. So when the exposure of the disease-causing organism is very brief, at a very time, maybe at just one time, the air is contaminated and you all inherit and you become affected. That is what we call point source epidemics. Point source epidemic. So the other one is what we call propagated epidemic. That is epidemics that occur from either the reservoir to the susceptible individual, and from one disease individual to another susceptible individual, and it continues to transmit in the society, passing the disease. That is what we call propagated epidemic. Propagated epidemic. So when you talk of point source, let us come back again, repeat what we said. Point source. So whenever you have what you call point source epidemics, those agents, those organisms that are causing point source epidemics, they must have a very short incubation period, and you have to implicate maybe the air, water, or the food are being implicated. That whenever there is what you call point source, you think of air, you think of water, you think of the food. That is what is implicated mostly. Something that is being exposed to people at the same time. An epidemic curve now, we have been showing you some graph, and those graphs are what we refer to as epidemic curves. And then that is when you plot number of cases against time. You find out we are doing a epidemic curve. An epidemic curve is a graphic expression in which the incidence rate of the disease is plotted against time, and is usually in form of frequency histogram or frequency polygon. You find out some bar chart showing them. When you plot the top of the bar chart, you are now plotting the graph, what you call epidemic curve, and then the shape of the epidemic curve. So let me show you. This is an example of epidemic curve. An epidemic curve. This is an example of epidemic curve, whereby this is the number of cases, this is the number this is time. So this is the shape of the epidemic curve. It depends. Sometimes the shape will be flattened like this, sometimes will be like this. So that shape, this shape of epidemic curve, it depends on the population size. The population size deals with the number of epidemics. If there is high population, that means the graph will be very lengthy. When a very low population, the graph will be very short. So also number two, the proportion of susceptible in the population, proportion of susceptible cases at that population. When the disease just occurred, so what is the number of susceptible cases? For example, if the number of susceptible cases in the population is very minimal, that means that the disease will not be prolonged, it will just die out. Because if it has, maybe you have very few cases of susceptible individual, so you find out those individuals that are resistant, it will not be affected with the disease, and thereby number of the susceptible will quickly finish, and then the disease will die out. Number three is the number of cases at the start of the epidemics. That is only when we are talking of propagated epidemic. But when we are talking of common source epidemic, that will not hold. When we are talking of what we call the propagated epidemics, that is epidemics that is from those are brought to the susceptible individual, from one disease individual to another susceptible individual, then we are talking of the number of cases at the beginning of the population of the disease. So you see the epidemic curve, when it rises up, then it will fall down. That is epidemic curve. It will rise up, number of cases will continue to increase, then it will now decline down. So you see what is happening at for example, let's say A is the number of cases increasing, while B is when it reaches the plateau, and then when it is coming down, that is C. So at A, number of cases are continuing to increase because there are more susceptible individuals in that population. Number of cases will increase. After the time when it reaches what we call threshold of infection. Threshold of infection is the number necessary for the infection for the infection to reach its high peak. Then it will begin to to die out, to begin to die out. Epidemic threshold. So when the disease reaches a threshold of epidemic, then they will begin to die out. So at sea, that's where it reaches threshold of epidemic, and then from there it begins to decline into sea, because a number of now susceptible cases has finished. There is no more transmission of disease from either susceptible individual, from one individual disease to susceptible individual person. So you find out the disease will die out, and that is what is happening in the epidemic. Now the last one, that is the fourth one. The fourth one is what you refer as pandemic, worldwide. An epidemic that is worldwide, affecting many countries, like what you observe during COVID-19. Many countries, they have a disease of epidemic cases in the area, and then it is now occurring in this country, occurring in other countries, in many of the countries. That is what you call pandemic, affecting many countries. A disease occurring, an epidemic of worldwide nature and affecting many countries. Thank God. Thank you very much. I hope you enjoy this lecture. Until we meet again.